In this video, we have the integral of 4 minus x over the square root of 4 minus x squared. Now, to evaluate this, we can see that the derivative of 4 minus x squared is minus 2x. We have a minus x up here, but we have the 4. So if we didn't have this 4, we could use just a standard U-substitution and let u equal to 4 minus x squared. Now we could break the integral into 4 over this radical plus minus x over this radical, and we could use a standard U-substitution with the one that has the minus x in the numerator, and the one that has the 4 in the numerator. We have this integral right here, the integral of du over the square root of a squared minus u squared is given by this formula here, arc sine of u over a plus c. Now if you have an x here, it's no problem. Instead of the u, you have an x over this a. This could be, in our case, it's 4, so a would be 2. In some cases, you might have to use a standard U-substitution to get it to this point. But in our case, what we're going to do is this. We're going to break this up into two integrals. So the first one, I'm just going to have minus x over the square root of 4 minus x squared. And that's going to be plus, this will be a dx here, and then we'll have plus the integral of 4 over the square root of 4 minus x squared. And this will be dx. And I can just work each integral here individually. So for the first one here, I'm just going to let u equal to the radicand in the denominator there at the square root of 4 minus x squared. Let u equal to 4 minus x squared. Then du would equal to the derivative. 4 minus x squared is minus 2x. This is dx then. And then we divide through by negative 2 here. The minus here. This is 2 here. And this will just give me an x dx on the right side. So this will equal to, so I'm going to do this first one first, and then bring down the next one. So in this one then, the x dx here can be replaced by minus du over 2. So I just put the minus 1/2 out in front. And this will be the integral of x dx again is replaced by minus du over 2. There's the minus 1/2, and then this will be the du here. And that's over the square root of 4 minus x squared, but 4 minus x squared, that's your u. So this is the square root of u here. And then I also have this minus here. So the minus, and then this was a minus, so these will cancel out. So this will be a positive right in front. Positive 1/2. And to integrate du over the square root of u, I'll bring that up to the top, so it'll be u to the minus 1/2. This will be du here. And then with just basic integration here, we add 1/2, right? We add 1 rather to the negative 1/2. That'll give me 1/2, so this will be u to the 1/2. And then we divide the coefficient by that, so that'll be 1 here. So that'll leave me with u to the 1/2, or the square root of u, but u is 4 minus x squared. So again, I brought this up to the top, became u to the negative 1/2, and then I added 1 to the exponent, it gives me a 1/2, and then of course divide, doing the integration, divide the 1/2 by 1/2, I get 1. So this leaves me with u to the 1/2, but u is 4 minus x squared, and the 1/2 of course can be written with a square root. So that takes care of the first integral. Now for this one here, we can use the formula that we just looked at, where this was du, instead of dx it was du, and then this was a squared here minus u squared, but in this case x is the same thing. X is the same thing as a u. So from here we go directly to the answer. So the formula was, and this plus here after two integrals. The constant, I can just bring it over here, because remember this was just a du here. It was du here, which of course is the same thing as your dx. And it was a squared, in this case a is 2. 2 squared is 4. And instead of u, this is x. Same sort of thing. So it was the arc sine, or sine inverse, you can also write it. But arc sine of u over a. In our case, the u is x. This will be x. And it was then x over a. In our case, this is like, in the formula it was written this way, a squared minus u squared. But x plays the same role as u. And then because we got 4, so a would be 2, so it should be x over 2 here. And then of course we have this constant, which we could bring out here. You get the same answer. And then the 4 comes along for the ride here. And then it's plus the constant of integration. So again, we took the given integral, broke it up into two integrals. We used a standard U-substitution over here on the first one. And over here, pretty much went directly to the formula. In the formula, instead of u, we have an x here. So this is the final answer then. The square root of 4 minus x squared plus 4 times the arc sine of x over 2 plus the constant of integration. Thanks for watching. We'll see you next time.